So this is a three-phase system of soil or three-phase soil system, whatever you call. Instead of reading this, I shall just try to explain all this through this diagrammatical representation. What is a soil? It is a mixture, you can say, or having three uh, contents. What are they? They are solid particles, or you can call them as soil grains. Then there is air, which is represented with these hollow circles, and there is water, which is represented with these horizontal dash lines. Okay, so actually a soil is uh, constituted by solid soil gradients or grains, air, and then water. Water can be treated as moisture also. So if you consider this particular block, it is having certain volume and certain weight. So if this soil mass, if you are considering, so the volume of soil mass will be or can be distributed among these three ingredients, you can say. Okay, volume of solid plus volume of air plus volume of water in general. Okay, similarly the weight can also be considered as weight of solids plus weight of air plus weight of water. So this three-phase system of soil, it is nothing but the soil mass made up of solid, liquid and gaseous matter. Okay, the solid particles, we can call them as soil grains. Free space is there. Now, uh, in a soil mix, we are unable to see the free space between the two soil grains, isn't it? But still it is there, and it is at micro level, and we cannot see it with naked eyes. So whatever the void is there, the empty space we call between the two solid particles, it is uh, filled with water as well as air. So instead of water, there can be any other liquid. So usually what we are saying is liquid phase, we are generally referring to as water, and gaseous phase, we are calling it as air. So liquid phase fills the void partly or wholly, and gaseous phase, it fills the voids which are not filled by water. Okay, so here the three phases are randomly mixed, forming a complex soil structure. It is complex. They do not occupy separate spaces for each phase. Okay, so the relative percentage and arrangements of these materials, they are responsible for soil mass properties. What are they? Let us see in the coming slides. So whenever you are studying or analyzing a soil system, you need to consider different phases of soil. Okay, let us see what are those different phases of soil. First and foremost important is three phase. Okay, so three phase system of soil, and usually we cannot separate out the three different phases. Okay, but just to understand and analyze it appropriately, uh, we need to represent the three phase system of soil in these three different parts. Okay, let us say what are these three parts. So these are the three parts. Bottommost part is solids. Above solids it is water, and above water it is air. Okay, now a soil structure does not necessarily have solids at the bottom, water in the middle, air at the top. No. What we are doing is, in just to understand a soil system, we are representing different phases of soil like this. Okay. This total complete rectangle is the total soil mass or total soil system. Okay, it is made up of solids, water, as well as air. And as far as volume of the soil mass is concerned, it is from bottom to top. As far as total weight is concerned, it is also from bottom to top. It means if you want volume of soil mass, it can be divided among two parts: volume of solids plus volume of voids. Voids will be occupied by water and air partially. Okay, it will be occupied partially. So overall volume of soil mass, it will be volume of solids, if you can see here, plus volume of air plus volume of water. Okay. Similarly, weight of the soil mass can also be represented in the form of this equation: volume of solids, weight of solids plus weight of water. Here, weight of air we are not taking into account because there is negligible weight. You can visualize or realize. Correct? Are you getting this, friends? Weight of air. Hello? Friends, am I audible?
Yes, sir.
Okay. So weight of air, please remember, it is negligible, whereas there is some considerable amount of volume of air. Okay. So here weight of air is negligible. So it is constituting only constituted by weight of solids and weight of water only. Whereas volume, it will be constituted by all three: solids, water, as well as air. So this is our three-phase diagram of soil system. It is just a representation. Now, there can be a state of soil where there is no water at all. Another state can be that there is no air at all. In that case, what is to be considered? How to analyze this? Let us see. Type of conditions in three-phase soil system. So first condition we shall see, dry condition. Okay, when there is dry condition, it means there is total absence of water in it. Total absence of water. So when there is no water, the three-phase system uh, becomes a two-phase system of dry soil. Okay, what happens in this condition? The combination of air and solid particles takes place. So this is the representation of that particular dry condition two-phase system. So when the soil mass gets completely dry, the free spaces, okay, or voids in between the particles are filled with only air or only by the gaseous phase. Okay, voids are occupied by air only. Here, the water is completely absent. Volume of the total soil remains same. Please remember, volume of the soil mass, it completely remains same, and volume of voids becomes volume of air. Okay, volume of voids becomes volume of air. As far as weight is concerned, for practical purposes, we are considering weight of air as 0. So total weight of the soil system is only constituted by weight of solids. Okay, soil grains only. But this is the equation when the soil is in completely dry condition. There is absence of water in this system. Okay, so this is one state. Another state is the saturated state of the soil, saturated condition. This is also a two-phase system, but this is of saturated soil. Here, the voids are filled with water and it is completely free of air. Okay, it is completely free of air. What is the meaning of saturated? It means water has absorbed the water completely so that there is no air between the two soil grains or soil particles. Okay, what happens here as far as the equations are concerned? Volume of the total mass, okay, volume of the total soil mass, it is constituted by volume of solids and volume of water. And total weight here, it is constituted by weight of soil plus weight of water. So this is the second condition of the two-phase system. Okay, so try to understand, when is weight of air negligible? Always. In dry state, total weight of the soil mass will be constituted by only solids. In saturated condition, total weight of the solid mass or soil mass, it will be constituted by only solids. Whereas volume for the two-phase situation, in dry state, volume is volume of solids plus volume of airs. For saturated state, it is volume of solids plus volume of water. And when there is three-phase system, volume of the total soil mass, it is constituted by all three: solids, air, and water.